So, we're diving into one of the biggest mysteries out there, our own origins. And you know where we're going to look for clues? Not in some giant telescope, but in the tiniest, most ancient specks of dust from space. Yeah, seriously. Let's see what these little guys have to tell us. I mean, think about it for a second. Where did all the stuff that makes up, well, us, actually come from? The carbon, the organic compounds, the basic ingredients for life itself. Did it all get started right here on Earth? Or was it maybe delivered from somewhere way out there in the cosmos? Well, back in 1984, a team of scientists had a pretty wild idea for how to tackle that question. They decided to look at this constant, almost invisible shower of dust that's always falling on our planet. Their hunch? That these microscopic particles, scooped up from the very edge of our atmosphere, were holding on to secrets from the very, very beginning of our solar system. Okay, so first up, ancient dust from comets. We're going to be examining these little time capsules. So what is this stuff, really? This isn't just random space junk. Nope. We are talking about incredibly old, perfectly preserved relics, like tiny little time capsules that have been floating around for billions of years, probably flaking off the tails of comets. All right, the official name for these things is chondritic porous micrometeorites. Yeah, I know it's a mouthful, so let's just call them CP micrometeorites. The name basically tells you what they are. Porous means they're kind of like a sponge, and micro means they're ridiculously small. We're talking smaller than the width of one of your hairs. But here's the kicker. They're packed with carbon. And how do we even get them? Scientists use special planes to fly way up into the stratosphere and basically vacuum them up. It's pretty cool. So what's the big deal with these little specks? Well, let's look at their profile. First off, they're made of primitive material. This is the original stuff from when the solar system was just getting started. And as we said, they're super rich in carbon. Here's something really important. They're incredibly fragile. That's why they don't survive coming down to Earth as a big flaming meteorite. But that fragility is actually a good thing. It means they're likely pristine, unchanged messengers from way, way back. All right, next section. Clues under the microscope. Let's see what the scientists actually saw inside these ancient grains. So once they had these precious little samples, they did what any curious scientist would do. They put them under an incredibly powerful electron microscope. And they weren't just looking at the surface, oh no. They were zooming in to see what was happening right down at the atomic level. And what they saw was, well, it was a total game changer. The carbon inside these particles wasn't just sprinkled in there randomly. Not at all. It was arranged in these really specific, organized patterns, right alongside tiny little grains of iron, nickel, metal. This wasn't a messy clump of stuff. It had a structure. And whenever you see structure in nature, it's a huge clue that some kind of process made it that way. Okay, so take a look at this. This is what they actually saw. On the left, you've got this little hexagonal grain of iron nickel carbide. But now look at the image on the right. That's the super zoomed in view. See that thin film that's perfectly wrapped around the grain? That's a mantle of pure carbon, only about 25 angstroms thick. We're talking just a handful of atoms. This perfect little coating, this was the smoking gun they were looking for. And that wasn't all. They also found other, even weirder things. Check this out. They called it filamentous carbon. You can kind of think of it like a tiny hollow carbon tube, and inside there are even smaller little mineral bits trapped. So finding both these perfect carbon shells and these weird filaments, it was screaming that some very specific kind of chemistry had to be going on. Which brings us to our next section, a tiny chemical factory. This is where we figure out how these carbon structures could have formed. Because all these clues, these precise arrangements, they all pointed to one stunning idea. These dust grains weren't just passively carrying carbon. No way. They were acting like tiny little factories, actively building complex stuff out in the cold, empty void of space. The scientific name for this process is heterogeneous catalysis. Sounds super complicated, right? But the concept is actually pretty simple. All it means is that you have a solid surface, that's your catalyst, and it helps a chemical reaction happen in a gas that's flowing past it. The surface itself doesn't get used up. It just provides a place for the chemistry to happen, kind of like a tiny workbench for molecules. And here's the crazy part. This isn't some bizarre alien chemistry that we've never seen before. The scientists looked at these structures and had a light bulb moment. They realized it looked exactly like the result of a process we use right here on Earth, in big industrial plants. It's called the Fischer-Tropsch synthesis, and it's used to turn simple gases into more complex fuels.
So, you want to know the cosmic recipe for making complex carbon? Here it is. Step 1, you start with a simple gas, like carbon monoxide, just floating around in the cloud that formed our solar system. Step 2, that gas bumps into one of our tiny iron-nickel dust grains. That's our catalyst. Step 3, the gas reacts right there on the surface of the grain. And finally, step 4, what do you get? Bam! New, more complex carbon structures get laid down, forming those exact same mantles and filaments they saw under the microscope. It all fits.
All right, final section. Forging life's building blocks. This is where we connect what's happening on a microscopic dust grain to the biggest question of all. Because this discovery, this wasn't just some neat little fact about space dust. It had huge implications. It gave us a plausible way that the essential building blocks for life could have been made, long before Earth was even fully formed. And in their original 1984 paper, the researchers laid it out pretty clearly. They said that some of the carbon in this dust was put there through heterogeneous catalysis. Now that might sound a little dry, but make no mistake, that was a bombshell. It was the first real physical evidence for a process that could build complex organic stuff out in the harsh environment of space. So let's just boil this all down. The big takeaway is this. These tiny little specks of dust weren't just delivery trucks bringing carbon to the early Earth. They were the factories. Imagine billions of these microscopic factories just drifting through that ancient cloud of gas and dust, grabbing simple molecules and using their metal surfaces as a workbench, churning out the more complex organic compounds needed to get life started. And that leaves us with one last really mind-blowing thought. For millions of years, as our planet was coming together, it was being constantly showered with this stuff. So, could it be? Could these countless tiny factories, all working together across the solar system, have been the spark that kick-started the chemistry for all of us? It's an incredible idea to think about, and it all started by looking closely at a single, tiny grain of cosmic dust